Hi everyone. In today's video, we're going to see about transformers. So, transformers, in the sense, it is a very important topic in current situation in AI. So, your entire LLM is based on that. Whatever you do, you learn, you teach. In these days, it is completely on LL, I mean, transformers. So, don't skip any part in this video, or else you won't understand. Uh, because when you know what is transformers, it will be easy to learn anything in future in AI. So let me explain what is transformers is. Think, imagine that I am someone who knows only Tamil, and I wanted to communicate in English. So I hire a translator, and this guy knows Tamil as well as English. So what all things are I say to him, he just extract the context from it and convert that language into English with the same context and translate to another person. So this is a simple translator, and that guy who translates stuff is your transformer. So whatever the form that you take from one form to another form is a transformer. Any example you take, like giving text prompt and convert that into image, and image into text, and your prompt just making a video. So everything in between makes possibly happen to have a transformer. Without transformer, we can't do anything these days. Why transformer we need is large language model, of course, and it need to handle so many vocabularies, but vocabularies. So when we take vocabularies in the sense, imagine English have 26 letters, right? With 26 letters, we can form many words. With words, we can form sentence. So how many sentence we can possibly make? It's a billion, trillion stuff, right? So in order to understand that, we need a mediator who can know what it is what. We can't just do every time with giving feeding the data into it and getting to know, or trying to produce something or new product with that. It is, I'm not going to say it is impossible. It is very costly. So when we hire or rent an LLM from any companies like OpenAI, Gemini, it is easy for us to build anything with ease because it already have large vocabularies and huge corpus it has. So it also understands what is what, and we don't have to teach it. So that is where the transformers actually plays a major role. It actually helps your LLM teach and understand stuff. With the help of transformers, they build these kind of LLMs to make our own product. I hope you guys understand what is transformers is and how much important it is. So without getting any delay, let's just proceed with how to build your transformers from scratch. You may question like, why I'm going to build, or how can I build transformers from scratch? Uh, I don't have large vocabularies or GPU and all. You can rent a GPU if you want and train your transformers on your own. There are like different transformers which is available in Hugging Face. They have trained their own transformers, built and published it for open source. So it is not something impossible to create one. It is there, but it depends on for what you wanted to build. So there are like so many different things in that. So without taking the time, I'll just move on with the building transformers from scratch, of course. So here, if you take, I just gave separate parts. I splitted transformers, making transformers into six different parts. Six in the sense, five different parts. Sixth part is your complete version of transformers. So if you take here token embedding and positional encoding, just imagine you're going to teach a machine, uh, and you're going to make it to think like a human. And how we try to teach this machine is we feed a lot of information to it, possibly everything. Like a child, we need to feed every possible information to it so that it remembers everything and behave in a way that you want it. So first step is your token embeddings and positional encoding. So embeddings we know, and embeddings and encoding both plays a same role when it comes to text. It is going to convert your text into numerical format, but in a different way, a different numerical way. Encoding is your grid, where for every present tokens or word in your sentence, it marks as one, and otherwise it is zero. You remember the grid that we make for one hot encodings, 0001 for present word and zeros otherwise. So it is same, but here we are using positional encoding because we need to know where the exact word is present in your sentence. Otherwise there is no meaning, right? Here we are trying to build a model where it's a auto completion, where whenever you're typing, it should recommend the possible outcome of next upcoming word. So that is the outcome that we are expecting to build in this transformer. This transformer for. So we need position, right? So for that, we are using position encoding. So whenever particular word comes, and it should know the upcoming word, like what are the possible words that can possibly occur next. So that is for that we need a positional encoding. And token embeddings is completely different. It is assigning weight to your embeddings because we need to convert your text into vectors. So it will be like uh, numbers of like 0.8, 0.9, minus 0.1. So vectors will be assigned for your entire sentence, splitted with splitted by, sorry, a sentence splitted with every tokens in it, word by word. So we need to convert that into vectors. So embeddings is for to extract context from your sentence. So encoding is to identify the position of every word that you give, but embeddings is to extract the context from the sentence that you give. So when we say the cat sat on the mat, it identifies what all the important words which is present, like cat, sat, on mat. So it should understand what is what. And we have like why we need both in one position is like to capture the meaning, and we need to capture the position of every possible outcome that we make. Then only we can possibly try to identify the next word. Okay, so here what we are doing in this code is we are defining the vocabulary size and model dimensionality. So vocabulary size and model dimensionality, that is your embedding matrix. We are defining a matrix, and we are assigning a token ID for every matrix that we are forming, so that we don't lose the track of your sentence or the words which is obtained. Given. Next is positional encoding. We are defining a positional encoding class with the same model dimensionality and maximum sequence length we are giving, which is of a 512. It's a default value. Default in the sense which can balance your entire model. Same goes with this 10,000 constant value for your sine and cos encoding calculations, functions. So why 10,000? If you know this paper, attention all you need, that is where they mentioned we can't just go with too short, which is 100, and too large dimensions, which is 1 lakh. So we are going with 10,000, which can balance your entire dimensionality so that we don't lose any information, and it won't overfit. We can't just, there won't be any fillers in it, and it will be balanced enough to have your entire model, your transformers basically. So we are using 512 based on that, and we are using 10,000 constant size to calculate the sine and cos functions for position encoding particularly. So with the help of this, we can calculate the position encoding. If you are seeing this, so this is how the token embeddings plus position encoding matrix will look like. So we are giving weights for every word that we are giving. So weights in the sense we know, right? So this much importance that particular word carries. So that is why it all needed. So this is like very basic step and important step to start with. Otherwise, the other remaining steps are easy. If you understand these things, the remaining part will be very easy to process with. So we need to teach the model what is what. If you are joining school, we will be assigned with ID, names, and all, right? To call and go beyond. I mean, to process next, like the performance check, everything will be monitored based on the ID and our presence, right? Because everybody have like different face and all, but we need names in order to proceed further. When we write exams, we can't just, teachers can't remember our face. They'll know the names. So that is our process. So the same thing, we are assigning weights for every word so that the machine can easily understand, oh, okay, this is have like high, so this have high weightage than the other things. So that is how, so we can know what have high weightage and all. So you can ask me, we can go only with encoding, right? Why we are going with embeddings? So if we are going with weightage alone, only the position encoding, we know like after this word this comes, and we know the importance also, like this have like weightage and all. But when we don't know the context of it, without assigning the weightage for any word through embeddings, the vectorization, if we didn't do, it won't understand what is cat. If it identified cat as mat, like non-living being, what mat will do? So if it just misplaced the position in the place where cat uh, as mat and mat as cat means, we can say the mat sat on a cat. So the entire context differs, right? So we need both. This is why we are moving to next step. If you understand, if you understood this step, you're you're in you crossed half of the ocean. The remaining things are very easy. You will know. See, self attention mechanism. So here we are teaching the purpose, why we join school, why we are going to college, why we need money. So these are the purposes that why. Why in the sense like the query we need to answer, and the key and values. Query in the sense like what is what? Cat is a living being, and mat is a non-living being, but it has a purpose. It has values. Something can sit on top of it. That is your key. Like information that it possesses. It is an object, but you can use money. That is mat. So these kind of information that you are feeding into your model, and that needs attention. So we are using softmax here in order to make your probability between 0 to 1, which we know. We are using activation function in order to have the summation of the sum of outcome of all possible words supposed to be 1. So for that we are using softmax and the entire forward neural networks, and we can have a visual representation on your weights. The weights we know, right? The every word it carries a weightage, which means we say its importance. I mean the attention it required. So when we say the the first word, when we are adding the, The cat have higher weightage to the because it can possibly come next because we can't say the mat. It is a non-living being again. It is an object which have purpose, but we can't mention the for it. For cat, of course, it is an living being and a real object, and we can just possibly have to refer with the and sat have the the upcoming weightage, which is next to cat, and on we can't, we never, and same thing, mat. It is on least. So that is how the have like the second highest. Sorry. Yeah. The third highest. Sorry, and second highest we have is sat. So why the is not having the the second highest score is because cat the we can't say, the cat we can say, but cat the no, cat sat we can say. So the probability of upcoming word can be sat. So this is why the second highest score. Same goes with sat. The second highest score for sat is on. Obviously, sat on is a more probable word we can add to next to sat. On is mat again, on table, on mat, on the floor. We can say those things. So this is the visual representations of weightage for every word that we use in the sentence. Yeah, if you're noticing here, I'm using vocabulary size of 1000, and the model dimension is 64, and attention heads is 4. I'll tell you what is it. And parameters so far we are using is embeddings. For embeddings we are using 64K, and attention we are using 12K. Yeah, next we'll proceed. I hope this has a neural network structure, but we are feeding the information, the purpose, the machine need to know why it is processing the entire information. Then only it can go beyond, it can think. For that we are feeding these information. So multi-head attention, I'll tell you what is multi-head attention. So probability of getting the cat sat on mat, this is one way. There are other probabilities we can try, even though it does not have a meaning. The mat sat on the cat, we can say, and sat cat on the mat. So there are like possible ways of doing it. So we are like trying to add these things so that we can have like different probabilities, and finally we can compare these things along with that. Imagine like you are in a class and your lecturer is taking class and you're making a note out of it, and later you will add more information when you discuss, when you study alone. So you'll add more information, right? For that we are doing this multi-head attention is we are feeding information, more information. You will have a original copy and additional information you will have. So combining both, the machine, the model will forget the how to say, the least impactful results. It will forget that, and it will remember the actual and beneficial output. For that we are using multi-head attention. I love. Okay. Here it learns different types of relationship, multiple heads. That is fine. So here head 1, head 2, head 3, head 4. And finally, we can select which is performing well, and so that we can have multiple recommendations. The cat sat on the floor. The cat sat on mat. The cat sat on the table. So we can have like these possible recommendations. When we Google, we will have recommendations, right? So this is how these are the heads which we are like seeing here, no? So these are the possible outcomes that we selected out of it. So the head is 4 here, And same vocabulary size is 1000. So nothing much. It is going to have your possibilities. We have given the positional and context information, and we gave purpose, and we are giving possibilities. The next is your regular thing, the traditional way of training your any any kind of data inside machine learning. So this is your feed forward network. What you will have in feed forward network, you will have input layers, hidden layers, and output layers, right? And that you have same thing. Now, no change in it. So Relu we are using. Relu in the sense it is very expensive. So we can handle non-linearity and we can get good and effective results when we are using Relu because it eliminates all the values below zero. So we can just have those non-linearity. We can maintain the non-linearity in order to get the accurate and effective results so that it will help the model to learn faster and effective way. Effective in the sense like how much time, I don't know, because it depends on the number of layers that we put and iterations that we make. But the quality will be very accurate when we use Relu in these kind of things. So we are using Relu in it, and yeah. So it's your simple thing, the basic input, hidden, and output layer, and we don't have much on that. So hidden layer should be 4 times larger than your input layer. It's supposed to be 4 times larger than your input layer. Just keep an eye on that. So with that, we can, you know, train the model and have the probabilities. Now let's see the parameters so far that we used for feed forward is 32K. I'll tell you one thing because this is the vocabulary size is 1000. Imagine that we are using a lakhs of vocabulary in size. How we will train? That is why we are buying LLMs. We can't do that. We can't train such large language models, but we can do for 10K, up to 10K, 50K, or even lakh we can do. But parameter size will increase based on that. You can rent GPUs if you want to have your specific transformers. If you go and check this Hugging Face platform, the website, the entire hub will have a lot of transformers. Most of the transformers have been trained by, simple machines. It may be any companies that they have trained or individuals. They have did that. So don't worry about whether I can do it myself or it depends on the vocabulary size. Just stick to the size limit and create a simple transformers and see like how you can achieve the outcome of building a transformers and make it open source. Okay, just make it open source so that people can review and let you know like how you can actually improve it. So use these kind of platforms for it. Next, the last step is layer normalization and residuals. So why we need to use normalization and residuals is in order to balance your model when you are training it because it may exceed the limit or the vector size may go beyond and it will lose the context. It may lose the information and entirely give you a different outcome. Just imagine like the cat sat on water. If it gives in that way, because we have given the attention, right? The attention feed forward we gave. It have original and the new thing which it learns. What if the new thing it learns is a false information and it misbehaved entirely? Because we are not feeding with text, or we are not feeding this information to a human being. It learns everything from a number. So we can't just play in that or twist it. For 0.01 of value or vector, if it gives 100, the value becomes 100, means how much variation it is from 0.01 to 1000 or 100, how much variation it is, and how much information loss it has. An entire context will change, and you will have like completely different outcome. The cat sat on a dragon, the cat sat on a dinosaurs or something. It will given that way. Yeah, it will actually. Oh, I'm not joking. So for that, we need residuals and normalization. It stabilizes your entire model. Okay, you don't have to worry about the data loss or information loss when you are trying. So that is why we are using residuals. So the flow will be neat, and your model will have the proper outcome. I mean, attention. So yeah, that's all. So you should have normalization and residuals in at the end, or else you can't achieve what you wanted to achieve, because it is not something which is common. You want to teach it like how to behave for a complete new set of data to it. Yeah, and that too, it reads through numbers. How you will actually add information to a number. So you need to follow these steps. Everything is, I mean, simple other than that. So at last, we have a transformer model. I'll share the code in my Git repo. You can take it and try it with yourself. And I also have posted that in my Discord. You can join and take it from there. And join the community also. We discuss some interesting stuff there. If you're interested, you can join and make use of the platform. All you need to do is just have an account in Discord. That's all. That is free. Uh, yeah, so complete architecture is your embeddings, turning your text into numbers, and giving the purpose and possibilities, and teaching it to behave. And finally, you will have a model with a stabilized way. Stabilizer, we know, right? It whenever we are like the current is diverting from somewhere, it just align. For that, we are using normalization. At last, you will have a model. So here, the cat sat on, the predicted next word is the, which is having a probability of 89 percentage. Yeah. With a multiple attention feed forward neural network, we achieve to have the as the next possible outcome from the sentence. Yeah. Yeah, that's all. I'll understand this. Take your time, just get to know everything. And probably I'll make a next video on GPT, because transformers are the base for GPT. When you understand this entirely, anything is easy. I mean, anything is possible, everything is easy. Yeah. So that's all, guys. Thanks for watching. Bye.